Hi, I'm Mr. Bo, and this is the first lesson in our June online 2-day math thing for M4 that we're doing. uh, for these 2 days, we're going to be learning about sets, and we're especially going to try and make it a little bit more interesting than just 2 days of learning about sets by learning about sets in Python and doing some basic programming and some data analysis and maybe look at what data analysts the kind of stuff that they do in a very simple way. So our first lesson today is Introduction to Sets, and we're going to talk about set equality. We've got a total of 4 lessons. So um, our objectives are that number one, we're going to know what a set is. By the end of this, we're going to use roster and description notation, so we'll talk about that in a minute. We're going to identify finite, infinite, and null sets, and we're going to identify equal sets. So we got quite a bit to do. Let's go ahead and get started. The first question is, what is a set? And it kind of doesn't need much description because in English it kind of works. A set is a group of things that you put together, and in math it's the same thing. It's a group of things that we put together. And I have an example here, and this example and all the examples here come from the website that's listed on your Google Classroom. So Keisha was in math class with her friend Angie. She whispered to Angie that she had just bought a set of winter clothes, a set of winter clothes. The outerwear collection includes a coat, a hat, a scarf, gloves, and boots. So the question is, what is the set of winter clothes? And it's listed right there on the bottom. Let me go ahead and turn on my pointer here. A coat, a hat, scarf, gloves, and boots. So if we write it, we're going to write a letter, a capital letter, equals braces, coat, hat, scarf, gloves, boots, and clothes braces. My next example, what is the set of all fingers? So here are my fingers. And what are my fingers? Thumb, index, middle, ring, and pinky. So when I write that out, go ahead, please. I write out P, capital P, equals open brace, thumb, index, middle, ring, little, close. And in my example 3, what are the set of all even whole numbers between 0 and 10? And this is a little bit more complicated, a little bit more mathy. It says between 0 and 10, so that means it can't be 0 and it can't be 10, and it must be even whole numbers. So remember, whole numbers are start at 0. So we're going to have not 0, 2, 4, 6, 8, and not 10. So when we write that out, I'm going to write out Q is equal to 2, 4, 6, 8. Put some braces around them, and make sure the Q is a capital. So there are two ways to write sets, and one is roster notation, and one is describing a set. We're going to start with describing a set because it's the easiest to talk about. We still have to put that capital letter and the braces, but then we just say what's in there. We just talk about what's in there. We have to be really specific though, so we can't leave any question about whether something is in or something is not in. But that's the easiest, and especially when we have lots of stuff, when we have lots of things, or we want to make it clear exactly what we're putting in there. But then the other way that we use most of the time is roster notation. So roster notation, we're going to learn a lot of notation in these next 2 days. We always use capital letters to talk about the sets. And so when we talked about that set of clothes, we used a capital A. But if we want to talk about an element of the set, one of the things that's in there, want to talk about a coat or a hat or a scarf or the gloves or the boots, we're going to use a small letter, a lowercase a, and we're going to use curly braces on the outsides here to close off that list of elements. So let's practice with it. I'm going to let you kind of take some notes and see if you can get it right. But there's no score on the notes. All right, so you just go ahead and take notes, and then the last one that we do, there will be a score on that one. So if you're wrong, don't worry about it, but keep trying to be correct.
be wrong until you're correct. And the only one that counts is the very last one that we're going to do. Okay, so my first one that we're going to practice on, let R be the set of all vowels in the English language. So vowels, the English alphabet I can read. Vowels are things that make sounds like ah, e, u, ah. Okay, so go ahead and take a second, write down a note, see if you can write down the set of all vowels in the English alphabet. Okay, welcome back. Let's see, did you get it right? Check yours. And I want to let you know that the order is not important. So if you put U first or you put O first, it doesn't matter as long as there are only five in there, and all of those five are the same that you got. If you got all the same five and you only have five, then your set is the same as mine. Next one, let G be the set of all whole numbers less than 10. So all whole numbers, remember its whole numbers start at 0, and it's less than 10. So go ahead. Welcome back. Let's check. Did you get it right? So here are the whole numbers. Whole numbers start at 0, and the counting numbers count up from 0, and then less than 10, it's less than 10, so it's not 10, and 10 is not in here. And if you had all these, and even if you wrote down 0, 2, 4, 6, 8, and then 1, 3, 5, 7, 9 after, or 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, as long as you have all 10 of them, and they're the same, then you got it right. Our next one is let T be the set of all days in a week. So you know the names for the days of the week. You guys are in M4 already. So go ahead and try to write a set for that. Okay, welcome back. Let's check, see if you got it right. All right, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So I wrote it starting with Monday because that's actually the international standard for when the week starts. But if you started with Sunday or you started with Saturday, it doesn't matter as long as you have all 7 days. That's the same set. And even if you counted them backwards, Sunday, Saturday, Friday, Thursday, Wednesday, Tuesday, Monday, your set would still be the same as mine. We'll get to that with equality later. So here's your actual practice question. This one counts. Try to get it right. Let X be the set of odd numbers less than 12. Oh, I'm sorry, this one doesn't count yet. Wait a minute. So let X be the set of odd numbers less than 12. Go ahead and try with your notation, with your note. Okay, X is 1, 3, 5, 7, 9, 11 because it's less than 12 and it's odd numbers. But again, if you put them in a different order, it doesn't matter. Our example 9, let Y be the set of all continents in the world. This one is a little difficult because all the continents in the world, not everybody agrees how many continents there are, but you try to answer that for what you've learned, and then we'll talk about it in a second. So this is my answer, and I'm from America, so I'm taught that there are 7 continents. Asia, Africa, North America, South America, Antarctica, Europe, and Australia. And if you add all 7 of those continents, even if you put Australia first, doesn't matter the order, then you got that right. And because the question is a little bit indeterminate, you may have something different. So some countries teach that North America and South America are one continent. Some countries teach that Asia and Europe are one continent. So you may have somewhere between 5 and 7 continents. But as long as it's what you were taught and they're full there, then that's okay for the answer. But if you want it to be the same as my set, you have to have these actual 7 continents, and they all have to be the same continents. So this is our check for points. So this one counts. So go ahead and read this and choose your answer. Okay, we're gonna talk about Python now. So how do we make sets in Python? Let me go ahead and switch to my coding environment here. This is my coding environment. If you want, I have a link to python.org. They have a shell there that you can use, and a Python interpreter from Python Anywhere, and you can use that if you don't have one. And W3 Schools, if you go to this website to learn Python, then you can see an example. And each example, they have a runnable, an executable version of it. So you can click, and then you can edit that too. So those are both okay. But I have a Linux computer that I use, and we have Python right on there, so I don't have to do anything special. So I'm going to go ahead and use this. So so the way we do sets in Python is not too different. Not too different from math, but there are a couple of differences. And I want to explain first that I am not a great programmer. I learned programming back in the 80s, before the C language was a thing, back when we were doing assembly and machine language primarily. So so I'm not great at modern programming, but I understand enough to do this. So I'm going to make a set here, and that is the set of the numbers 1 to 5, and I'm calling it set A. So we're not going to use a capital letter for that. We're gonna assign some other variable for it because it's computers, and we can't use the description method. So I can't just say all the numbers from 1 to 5. I can't tell a computer that and have it know what I mean. But you can see that that this is our set, and it remembers our set, and it gives it back to us actually prettier than I put it in, right? So or if I want to create set B, I still need those. Whoops. Need an equal sign too. Still need those braces, open braces. If I want to put things in that are called strings in computing, but I want to put words in basically, like a hat and a cap and a visor and a helmet. We'll say these are things that go on your head, and we need to make sure we close those braces. I have to put those in quotes, either double quotes or single quotes. Both work, but you should generally choose one and stick with it. And then if you want to see that, then you'll choose to print. So that's how that works. It automatically converted it to single for me. So so if you want to, yeah, that's how you do it in Python. Anyway, so let's go back to my presentation over here, and we're going to talk about elements of sets, and we've got a lot of notation over the next few days. So we're going to talk about what an element is. An element is just one thing in the set. One thing in the set. So we have two symbols, and one is this looks kind of like an E. And I saw a teacher a while back say that's epsilon, but it's not epsilon. This one, which we'll talk about in a second. So these is an element and is not an element of, and these are kind of similar to equals and not equals, in the way we just kind of like put a slash through them to mean not. So this one is read is not an element of. So you can see over here we've got A. The set A is set 2, 4, 6, and 8. So I can say 2, this funny E-looking thing, A, which we read as 2 is an element of A. And I can see 2 in there. I can find 2 in there. And 5, and this other funny looking E with a cross, a hash through it, A, 5, which we read, 5 is not an element of A. And I can't find 5 in here. I can't find 5 in here, so 5 is not an element of A. B looks at A, E, I, O, U, so that's all the vowels in the English language. So we're going to say E is an element of B. E is an element of B, and it reads out this way. W, I can't find W in here. So W is not an element of B. W is not an element of B. My set C, we have the odd numbers, less than 10, or less than 11, I guess. So 1, 3, 5, 7, 9, 7. 7 is an element of C. And 2 is 2 in there, 2 is not in there, 2 is not an element of C. D is -3, 2, -3, -2, -1, 0, 1, 2, 3, which is all the integers between -4 and 4. So -2 is an element of D, and 1/2, I can't find 1/2 in there anywhere, is not an element of D. So now it's time to check. We got 4 practice, and then we got 1 that really counts. Okay. So I have my set over here. R is equal to 2, 4, 6, or 8. Want to know 10. Is 10 an element of R? No, 10 is not an element of R. I have my set over here. S is the set 2, 4, 6, 8, 10. Want to know, is 10 an element of S? Yes, 10 is an element of S. Here we have some descriptions of our sets. D is the English alphabet. And here I have the Greek letter sigma. So is the Greek letter sigma in the English alphabet? No, sigma is not an element of D. X is the set of prime numbers less than 10. So we want to know, is 9 in there? Is 9 an element of that set? No, 9 is not an element of that set because 9 is less than 10, but 9 is not a prime number. 9 we can divide by 3. So our last one, A is the set of even numbers. We want to know, is 8 an element of A? Go ahead and write your answer, and this one counts. All right, so what about Python? Let's go back to my coding environment here. And we want to know if something is an element. And in Python, we use the word in for that. So I want to know, is 5 in set A? And it tells me true because 5 is in set A. And if I say 6 in set A, it will tell me false because 6 is not in set A. If I say, I have to use my quotes, visor in set B, it tells me true, but beanie, another thing that goes in your head, in set B, it is not. Okay, so that's how we check whether something is an element in Python or not. All right, we have 2 more things to talk about. First one is the kinds of sets. So there are finite sets and there are infinite sets. For finite sets, finite means it's limited. There's a limited number of things. So here we have A as the whole numbers between 0 and 100. So over here I have the numbers 1 to 99. And we use this ellipsis, these 3 dots, they're called an ellipsis, to show that it just goes, it follows this pattern, the same pattern. And we use that a lot in math. And for finite sets, we'll use it in the middle. Here B is all the primary colors, so we have the primary colors listed here, both the description and the roster notation for you. C, the description is the prime numbers less than 12, or if we use roster notation, 2, 3, 5, 7, and 11. And so all of those have some
limited number, we could count them. Or even if it's amazingly large, like something like all the atoms in the universe, it's still a limited number, and we can still put a number to it, even if you could say we can't count it. So when I say you can count it, that's not always true, but as long as you can put a number to it. And the other kind of set is an infinite set, which is infinite and not limited, and has an unlimited number of elements. So the question becomes, well, how do we use a roster notation? Well, there has to be some pattern for us to follow. So we have even whole numbers here. So 2, 4, 6, 8, and it just keeps going on and on and on. And so we put the ellipsis at the end. And we could put the ellipsis at the front too, not for this one. But if we needed to, we could put the ellipsis at the front. So sometimes infinite, you'll see, like integers, you might see an ellipsis and then -3, -2, -1, 0, 1, 2, 3, and then another ellipsis. Means it goes forever both ways. And this last one, y is prime numbers. Here's our prime numbers, but the prime numbers keep going. And one of the big things in math and especially information security is finding larger and larger prime numbers. And then the third kind of set we have is the empty or null set, and you can call it either. You can call it the empty set, or you can call it the null set. And we have two ways to denote that. We can either have empty braces here, open and close with nothing in the middle, or we can have this thing that kind of looks like a 0, but it's not a 0. Okay, so a null set means we have nothing. It doesn't mean there's 0. So if I have an empty bag and I ask you what's in the bag, you don't answer 0. You answer nothing. It's empty. Okay, so we can't list the things that are in there because there's nothing in there. So what about Python? Python's really easy for this. Sorry that it takes me a couple of seconds to switch to my coding environment here. So if I want to say define an empty set, I really can't use that null character there. I can only use this kind of open close brace thing. So okay, so you can see there, that's how we define a null set. And null in general is really important in computing. So again, null doesn't mean 0. Null means nothing. All right, so we have one more thing to cover, and that is equality and figuring out whether sets are equal. And I kind of talked about that before. So here we had this question earlier about what the prime colors are, and I have two people who wrote down answers. Eduardo wrote down red, yellow, and blue. I can read. And Angie wrote down blue, red, and yellow. And the question is, who's right? They're both right, of course. Not like Angie's wrong because she put the colors in the wrong order. You ask, what's on the table? If you tell me things in a different order than your friend, you're not wrong. So the same way for sets, order doesn't matter. And I've noticed lately Python kind of keeps the order, but like early Python, they just kind of spit out some, you never knew what order it was going to come out for the set. The set came out in just whatever order it was going to come out, but it didn't matter. So there are two things that are important. You've got the same number of elements, and I covered that up. Hold on a second. And you have to match the elements 1 to 1. So we have to have the same number of elements and match the elements. So here we both have 3, 1, 2, 3, and yellow matches with yellow, blue matches with blue, and red matches with red. And this is really easy because there are 3. But if you start having sets of 4, 500, 1,000,000 things, asking whether they're equal is kind of difficult, and that's where computers come in really handy. So here I have a couple of examples. We want to know if A and B are equal, and
So we want to know if they have the same number of elements. That's a good way, because if they don't, then automatically they're not equal. So don't waste your time with the second one. So this has 4, and this has 4, and are they matching? So I can go 1 to 1, 3 to 3, 5 to 5, and 7 to 7. So these two are equal. So let's see, are x and y equal? So let's see, do they have the same number of elements? 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. They both have 5, and do they match 1 to 1? A goes to A, E goes to E, I goes to I, O goes to O, and U goes to U. So yes, these are both equal. So let's look at example 3 and see if P and Q are equal. So here, apples, oranges, bananas, and pears. It has 4 elements, and this one, oranges, pears, and apples. They don't have the same number. This one has 3, this one has 4, so they can't be the same. And in sets, we can't have the same element twice. You can only put the one element in once, so automatically we know these are different. But if we really want to go in, we can see oranges here, and pears here, and apples here, and this one has bananas, and this one doesn't have bananas. So this one is a little bit more difficult. Let R be the set of all whole numbers less than 5, and let S equal 4, 2, 0, 3, and 1, which is out of order. Our sets R and S equal. So whole numbers less than 5, so it's less than 5, and it's not including 5, right? And its whole number starts at 0. So whole numbers less than 5 are 0, 1, 2, 3, 4. So there are 5 elements. Do we have 5 elements here? Yes, we do. And is it 0, 1, 2, 3, and 4? Yes, it is. So these two are equal, even though this one is the description and this one is the roster notation. So let's do some equality check. This is your turn. I want to know which of the following sets are equal. There are a couple of them. There are a couple of pairs of sets that are equal. So go ahead and take a second and look at that. Okay. So we're gonna ask about Python, of course. This is our last thing to do. So let me switch over to my coding environment here, and I am going to clear this out and start again so that it's at the top. So I'm going to create 2 sets. And my set A is equal to 1, 2, 3, 4, 5. And I am going to set my set B is equal to 5, 4, 3, 2, 1. And so I can print set A and make sure it's initialized. I can print my set B and make sure it's initialized correctly. Oh, there we go. Print B. I can print set B. Okay, and you can see it kind of reordered it for me. But if I want to check to see if they're equal, I'm going to say set A. Wait a second, I'll explain this. Okay, so this is a common thing in computers because this equals tells us to put this value into there, and we don't want to put this value into here. If we just have one equal, then, and I press enter here, what I'm going to do is I'm going to make set A and set B equal. I'm going to make them equal. I'm going to make set B equal A, but I don't want to know that. I don't want to do that. I want to know, are they equal? So here, this is a comparison. This double equal sign is a comparison in a lot of computer languages. So if we click that, then we'll see that it's true. And if I
make set C as equal to 1, 2, 3, 4, 5, 6, we can check that set C is initialized. Okay. Then I can check if set A is equal to, I can compare them, set C. So don't make the mistake of writing a single equal sign there. Most beginner programmers make that mistake, and then it's a problem. All right, so this is false because they're not the same. They don't have the same number of elements, and there's that extra 6 there. So we are going to have a programming challenge for you to do to practice using sets and set notation. So go ahead and come back to the classroom and visit me. Thanks.